All right, in this first video, we're going to check out some exponent rules and the practice problems that you'll need to know to solve the styles of questions that you see on the screen here. So let's get started. There are 6 questions I'm going to go over in this video. I'm not going to go over the basics of exponents. You can find those sorts of properties and videos online and other places if you need them. I'm only going to focus on the questions that you should be focusing on for my class. And the first question that we have is where we have a multiplication problem. I'm going to use a different color to identify my work from the question. What I observe right off the bat is that I have multiplication going on, and if I write this without the parentheses but with dots instead, dots to indicate multiplication, I have -5 and an x to the -2nd. I'm going to use the property of the commutative property, and I'm going to take the -2 and the -5 and I'm going to put them together. I'm going to put the x to the 3rd and the x to the -2nd together. And then I'm going to go ahead and focus on the fact that the x's have common exponents, same base, but common exponents, and the 2 and the -5 are simply multiplied together to give you 10. And since the rule is add the exponents, we're going to get 10 to the x power. X to the first power if you prefer, but you don't want to use the first there if you can help it. You'd rather just have 10 to the x. Sorry, 10x, not 10 to the x, but 10x. So that's your first solution. Second style of question, when you're still dealing with multiplication, but you have a couple other things going on. You have a negative exponent inside of a fraction. You have a negative exponent outside of a parentheses. Let's go ahead and take a look at this as well. If I were looking at this problem, the thing that I would focus on first would be the exponent outside of parentheses, because as an order of operations, that exponent is going to be the most important to me. I also noticed that if I then look on the inside, I see this guy as well. I'm going to be torn a little bit because there's a couple different approaches I can use. I think the approach I'm going to use actually is going to be trying to, and I don't want to use the word distribute because it's not technically distributing, but I'm going to apply that -1 to the 2 different values on the inside. 2 to the -1 is what I get on top, and x to the -3 times -1 is +3 on the bottom. And I'm not going to use parentheses anymore because I've used up that -1 that was outside of parentheses, and I have x to the 5th. I'm going to continue on, and I'm going to go ahead and keep 2 to the -1 just for now. I'm going to make the times x to the 5th part of my numerator because it was, when I look at a problem like this one, I think of it as an over, wrong tool. I think of it as an over 1. So that gives me the ability to make that x to the 5th on top, and I have x to the 3rd. Now I'm going to go ahead and deal with my exponents. I have first these guys, which since I have the same base, I'm going to be subtracting. I have 2 to the -1 and x to the 5 minus 3, and I'm not going to write that one out to save some space. And now finally I'm going to go ahead and deal with this exponent, which I don't like. I don't like it because it's negative, so I'm going to make it a 1 over 2 to the +1 times x to the 2nd. And then I'm going to finish this problem off in much the same way that I did before. This piece can be treated as a fraction where it's on the top. It would look like this. So I'm going to end up with 1 times x squared, which is x squared. And on the bottom, I have 2 to the 1st times 1, which is 2. And there is my final answer. X squared over 2. Third question. This one, you're going to see that, again, it's not the distributive property, but you're going to see me use that application of the 3 in the outside applies to everything on the inside. So I'm going to get 4 to the 3rd, m to the, now 3 times 3, I'm going to write it out this time because I'm going to have plenty of space to work with, 2 times 3, and on the bottom, 3 to the, I suppose it would be 1 times 3, and if I want to be consistent, I'll show it up there as well. Now, there's no negative exponents, which I like. That's going to make things a bit easier. I'm going to keep this as 4 to the 3rd. Let's see, 4 to the 3rd is 4 times 4 times 4 is 64. I have m to the 9th, n to the 6th, over 3 to the 3rd power, so 3 times 3 times 3 is 27. And that's it. I know that I can't simplify the 64 and the 27 because the 4 and the 3 didn't simplify, so I'm going to go ahead and say that multiples of those are not going to simplify either. The m and the n are the only instances of the variables m and n, and there's no negative exponents, so I'm all done. Here comes the next piece. Similar in style. Once again, you're going to see me. I'm not even going to hesitate. You're going to see that this is going to be a theme of mine. If I see a power on the outside, I immediately apply to the things on the inside. So I'm going to get 4 squared, x to the negative 2, y to the 4th. You can probably follow what's going on there. I'm multiplying the exponents. I have 20x, y to the negative 5th. And just because I want to save a little bit of space, this 4 squared right here, I'm going to go ahead and take 4 squared out and just make that 16, because I think we can all follow that 4 times 4 is 16. Now let's see what we can do. I'm going to go ahead and deal with, this time I'm going to deal with my coefficients first. The 16 and the 20, I figure I might as well simplify those right off the bat. 16 and 20 both have a 4 in common, so that's 4 over 5. And I'm going to leave some room here and here for some variable pieces if I need them. Let's go ahead and see what we get. When I deal with my x's, I have x to the negative 2 minus 1, and I have y to the 4 minus negative 5. Now let's go ahead and transfer this down. When I deal with the x's, 4 to the, let's see, x to the negative 2 minus 1 is negative 3, y to the 4 minus negative 5 is 9. One of those is going to have to move and the other one won't. You can see that the negative power is going to have to move to the bottom. The y to the 9th doesn't need to move anywhere, and I'm going to get 5x to the positive 3rd. And that's how I deal with negative exponents. I believe I have 2 examples to go. Here we go. This one looks a little bit more complex because it has 2 fractions. I simply want you to remember that in these fractions, I'm going to do an example of that first, I guess a version of that first example, where I'm simply going to write everything all together. I'm going to put the 6 and the a, so I'm combining all of this stuff up here all into one big piece. 6a, and then I see a squared, and then I see a b and another b, and I see a c, but it's squared. And on the bottom, I'm going to go ahead and combine all of that stuff together as well. There's not that much. It's 2 and c to the 5th. Let's combine, let's see, 6a to the 3rd, because I'm going to combine the 1 and the 2 together with addition. And I'm going to take the 2 b's and I'm going to combine those together with addition as well. So b to the 2nd, and c didn't really change. And I have 2c to the 5th. And now I'm feeling like I need to do a little bit more simplifying. The 6 and the 2, of course, need to simplify, and they become 3. And that's the same as 3 over 1, so I'm going to let that sit on top. I have a to the 3rd doesn't get changed, b to the 2nd doesn't get changed, and now if I clean up a little bit, I have c to the 2nd and c to the 5th. I'm going to use that subtraction rule. The subtraction rule there is going to be c to the 2 minus 5 is negative 3. And because I'm almost out of space on this one, I'm going to recognize that that negative 3 above the c is the problem. So I'm going to move this thing to the bottom, and when I move it, I'm going to, of course, have to grab the eraser tool and make that positive. And while it's a little bit sloppy, I can clean this up the tiniest bit. This would be my answer. And the final example. This one has parentheses with a negative exponent, and my theme is going to be the same. I automatically just do this. Keep in mind that there are other videos that show these different ways. There are lots of different ways to do these problems, and most of them are successful. This is just one of many techniques you can use. I'm going to go ahead and do the 3 to the, let's see, this is 1 times negative 3, so negative 3. I have a to the 2 times negative 3, so negative 6. B. Negative 5 times negative 3 is 15. I like that because it's positive. And c to the negative 1 times negative 3 is, again, positive 3. I like that because it's positive. Let's go ahead and take care of the negative signs. I'm going to have to create a fraction for this and do the elimination of the negatives. And I'll keep the positives on top where they were. And now I'm looking to make sure that I'm happy with that. I think the only thing I can do now is probably simplify 3 to the 3rd. That number is small enough to be reasonable. If you needed to leave your question with exponents, you could leave it. But 3 times 3 times 3 isn't the hardest question we've ever seen. So I think it's worth just multiplying. And I have myself a nice, clean-looking answer. I hope this video helps you get through the exponents in Algebra 2.